Hi everyone and welcome back. Today we're going to take a look at a little kit that I purchased from eBay, a little metal detector. So this thing is designed to pick up studs behind gyprock or plastered walls. A simple little circuit that took just a few hours to put together, and it wasn't without its problems, as you'll see at the end. So let's take a look at it now. So as you can see, I ended up with the meter out at the end of the construction, so all did not go as planned. It certainly seemed to show lots of promise to start off with, but after I fitted those clip leads and repowered it, the LED and the alarm was on all the time. So I jumped on the website and managed to find a copy of the circuit. So I didn't capture the fault finding on video, unfortunately, after I'd located the circuit and went back downstairs later on, but let's just talk through what we were seeing going on. The beeper and the LED were on hard all the time. Now that meant this transistor must have been on, and we can see that that transistor's base actually returns to 0 volts through this resistor, assuming that this transistor is off. So that will actually pull it hard on all the time. And when I checked the voltages around that PNP transistor, sure enough, we had around 0.6 or thereabouts on the base, and it was certainly on all the time because the speaker and the LED are on. So that meant that transistor Q2 must be off, because if Q2 was on, then the voltage at its collector, and therefore the base of Q3, would be close to VCC. Now, on checking the voltage on that particular transistor Q2, I found the base was actually returned back up to VCC as well. So it was most definitely off, and again, that's why the speaker was on. Okay, so that brings us back to Q1. On checking the voltages around Q1, I found that the emitter could be varied from 0 volts up to around 2.5 volts or thereabouts, and the base would be around 0.6 volts higher than that. And that's what I'd sort of expect, I suppose. The interesting thing is we have the collector of Q1 at VCC. Now, Q1 is obviously turned on with 0.6 volts across its base emitter junction. That collector should be sitting at very close to the emitter voltage in steady state conditions anyway. So that's obviously not right. So Q1 certainly looks like it's not in a healthy state. It looks like its collector is open circuit. And after changing Q1, I didn't have a 9018 transistor, but I ended up just putting in a BC548. Lo and behold, the circuit works again. So why did Q1 fail? Look, it's anyone's guess. Could be something to do with cheap, crappy Chinese components. You know, maybe I did something. Who knows? I can't really tell. But anyway, after changing Q1, the device seems to work quite okay. So all that's needed to do now is to design up a little case in Fusion 360. I'll have to get a little battery holder. Hopefully I can get something fairly quickly and get this little project out of the way. If you like what I'm doing, then please do like the video. If you'd like to see more, then please subscribe, and don't forget to hit the chime so you get notified when I post something new. And I'll put a couple of links here to some other videos you can look at.